Whoa, welcome guys. So let's solve this probability question. So this problem is taken from the first course in the probability theory, and I think some more questions are really interesting. So I film a solution and just play just meet you guys. So be sure to subscribe to my channel. So subscribe. Yeah, I mean I just want to mention you must subscribe to my channel. Okay, so. And click like button and leave the comment below. Okay, so the total number is a number from 1 to n put into urns. Also number 1 through n in such a way that the ball I is equal to go into an array of arms 1 to I. Okay, so this problem is that you can imagine that you have balls 1 and 2 and 3 up to n, right? And then you have arms. So let's maybe using different colors 1, 2 to n. Okay, and the rule is very strange that the first ball can only go to 1 urn. So why, right? And the second ball can only go to the first or the second urn. So yeah, the probability half go to 1, half go to 2, and the third one can have 1/3 go to 1, 1/3 go to 2, and 1/3 go to 3. And for the urns one, you have 1 over n go to 1. 1 over n go to 2, and 1 over n go to n. Okay. So the first question is that the expected number of urns then the empty. Okay. So the first question is the difficult one. Okay. So let's solve. Okay. So the standard way is like right. So just define I to be the random variable. Let's say I to be a random variable of i's urns. And such that if i's urn okay, so if i's urn, I should say i's urn is empty, then I click 1, right? Then else I define 0. Okay, so what we want to prove, what we want to compute is the expectation value of x, where x is defined to be sum of the I, right? So sum I means that the expected number of urns, so it's I from 1 to n and the EII. Okay, and also this can be written as I from 1 to n PII. Okay, so what PII means that the probability that the i's urns is empty. Okay. Yeah, so this is the key step. All right, once you understand this, everything will be okay. Okay, so let's ask about what is the probability that the first urn is empty. Right, this is impossible, right? Because the first one must go to the first ball must go to the first one, right? So the probability i's urn the first urn is empty is 0. What about the probability of the second urn? The second urn is empty. Right, so the second urn is empty. The second one, right? The second one must go into the first one, right? So it will be half. And the third one cannot go to the second one, right? Can go to the third one or the first one. So it's 2/3. And then keep going. So it's become n minus 1. So you can see it's basically 1 divided by n, right? Because it's cancelled. Okay. Okay, so what is the probability that the third urn is empty? Okay, so the third urn is empty. The third urn, right? The third ball must go to the first 2, right? So and the fourth ball, right? The fourth ball cannot go to the third urn, right? Can only go to 1, 2, or 4. So it's 3 divided by 4. And minus 1n. So it's, you can see cancel. So you get 2 n. 2 divided by n. Okay. So you see what is the probability that the i's urn is empty? Obviously, right? So the first term will be I minus 1 divided by I times I plus 1 to go to n minus 1, right? So the same is I minus 1 divided by n. Okay, so it's very easy. The answer for A will be I from 1 to n. Just take a probability to be I minus 1 divided by n. So it's n divided by I from 1 to I minus 1. So it's 1 over n. 1 plus 2 plus n minus 1, right? So and this is what the arithmetic progressions, right? So the sum will be n times n minus 1, n times n minus 1 divided by 2. So answer will be n minus 1 divided by 2. Okay, so that's the answer. You can check n equals to 2 for a reason, right? It's very trivial. Okay, so let's solve the second one. Okay, so second one says the probability that none of urns is empty. So let me just click this. There should be a way to click all of it, right? I mean, yeah, don't worry. Oh, it's a little bit waste of time here. Okay, but it's enough. Maybe I only need a very small space to solve the B. Okay, as I said, be sure to subscribe to my channel. Yeah, because I really need you guys to support to help me to keep solving math. The probability that none of the terms is empty. Okay, so let's maybe to solve this, let's maybe solving by like an induction or see very little check for n equals to 2. Okay, and for n equals to 2, right? The first one must go to the first, right? First terms. But what about second one, right? So if none of the terms is empty, then second one must go to the second term, right? So the answer for P n equals to 2 will be half. Why if n equals to 3, right? So if we have 3 and 3 terms, then then it's obviously that the first one must go to this, and the second one must go to the second, right? Because the second one cannot go to the first, and the third one must go to the third, right? So it's a half times 1/3, so it's 1/6. 1 divided by 6. Okay, so you see a answer, right? Suppose we have n ball and n arms. Okay, so the the n's balls must go into the n's, right? If the n's balls does not go to n's, then no other balls can go into this. So this guy must be empty, right? So will be 1 over n times. So this guy must go into this, right? But once he goes into this, then the situation is the same as the n minus 1. So it will be 1 minus n minus 1. 1 divided by n minus 2 to go to 1, 1. So the answer will be 1 divided by n factorial. Yeah, so this is a probability answer. Okay, that's it. I will see you guys in next videos. Be sure to subscribe to my channel. Thanks.